Okay, we are finishing up that last example on day 1 of 3 variable systems, looking at one more special case. So, following those same steps as before, I'm going to number my 3 equations. Looking at what I'm working with, on equation 1, it looks like I can get z by itself pretty easily. So, I'm going to rearrange this as z equals 6x minus 3y plus 16. Then I can substitute it into equations 2 and 3. Starting with equation 2, that will give me 3x minus 6y minus 3 times 6x minus 3y plus 16, which equals negative 12. I'm going to distribute. Combine like terms. Negative 15x plus 3y equals 36. That's my equation A. To find equation B, I'm going to substitute this expression for z down into equation 3. Distribute the 3. Combine like terms. And now I have equation B. Between the two of these, again, I want to use elimination so that I'm not dealing with fractions. And I'm going to look at my y's. Common multiple here would be 12. So I'm going to multiply equation A by 4. And then I'm going to multiply equation B times 3. And I end up with 0 equals 0. This means my answer is going to be infinite solutions. But what does that really mean? So when we had infinite solutions with 2 variable systems, that meant they were the same line. So with a 3 variable system, that means they are the same plane. But I want you to tell me, okay, what is a point on that plane? And the way that we're going to do that is by expressing each variable in terms of one of them. So I'm just going to start with x. I'm going to let x be equal to x. Now I need to know what y is in terms of x. So I've already got 2 equations, A and B, that only have x and y. So you can pick either. I'm just going to go with equation A. And what I'm going to do is rewrite this and solve for y. So I'm going to add the 15x. And then I'm going to divide by 3. And I get that y is equal to 5x plus 12. So whatever x is, the y coordinate is going to be 5 times that number plus 12. Okay, now the last thing I need to do is find z. So I need to plug in this expression for y and leave x alone and get z. So what I can do is use this first equation that we started with to make that happen. So this will be, pardon the bell, 6x minus 3 times, I'm going to plug in what we just solved for y, 5x plus 12 plus 16. So I'm going to distribute that negative 3, and I'm going to get negative 9x minus 20. So whatever x is, z will be negative 9 times that number plus 20. Once you have gotten to this step, I just want you to say, okay, let's say x is 0. Y would be 5 times 0 is 0 plus 12 is 12. And z would be negative 9 times 0 is 0 plus 20 is 20. Oh, and that should be a minus 20. Oops. So this would be negative 20. Okay. Now if x was 1, y would be 17, z would be negative 29. If x was 2, y would be 22, and z would be negative 39. Excuse me, negative 38, and on and on. So when you have infinite solution with a 3 variable system, you need to take it this step further and tell me what one or more possible solutions are.